and the implementation is quite straightforward. So, how do we implement this? Well, any ideas? Well, resistor derive. Very good. So, this voltage is R1 by R1 plus R2 times VDD, and the hysteresis window is twice R1 VDD by R1 plus R2. Right. So, this is where what is called the Schmitt trigger, and as you can see, if the input is very low, the output is high. If the input is high, the output is low. So, what kind of characteristic? It's inverting. So, this is an inverting Schmitt trigger. Right. So, for example, R1 is say 1K, R2 is 99K, right, and what is the and let us say VDD is 10 volts. So, when the input is large and negative, what is the output? It is an inverting Schmitt trigger. When the input is large and negative, what is the output? Plus 10. Okay. All right. So, and so what must be the input before the output goes to minus 10? Yeah, basically input must must be greater than 10 times R1 by R1 plus R2, which is 0.1 volts, for the output to go to minus 10. Correct? All right. Now, if the input is large and positive, the output is going to be minus 10 volts, and input must be less than minus 10 times R1 by R1 plus R2, which must be equal to minus 0.1 for the input, for VO to go from to plus 10. Is that clear? And what comment can we make on yeah, so the hysteretic window, hysteresis window is 0.2 volts. So basically, you have a window of 0.2 volts plus minus 0.1 volts to accommodate noise, basically. Okay. If you want a fatter window, what must you do? You increase the feedback factor to a number here it's 1%. You increase it to 5%, then the feedback window will increase by a factor of the hysteresis window will increase by a factor of. And so basically, if you stare at this picture, this is nothing but our non-inverting amplifier, except that the signs of the op amp have been reversed, right? And you would think that, yeah, I mean, maybe that's not useful, but it turns out that it is useful to generate characteristics like. So now, by the same analogy, I mean, let me work out an example of the opposite kind, where we started off with a non-inverting amplifier and then ended up with an inverting Schmitt trigger. If and this is a R2. So this is an. So what kind of amplifier is this? This is an inverting amplifier. Is there negative feedback or positive feedback? There is negative feedback. So VO by VI is nothing but minus R2 by R1. All right. Now, what comment can we make if we now interchange these signs? Make this plus and this minus, right? And let's again assume that we are working with dual rails. So this is VDD. This is minus VDD. Okay. So when the input is large and negative, so when Vi is large and negative, what will happen to the output voltage? Output will be minus VDD. Very good. Okay. So what is this voltage? Very good. So it's going to be minus VDD times R1 plus Vi times R2 by R1 plus R2. All right. So when will the output flip from minus VDD to plus VDD? So for this to flip, so for the to flip, what should we do? This voltage must be greater than 0, right? So basically, what should we do? Vi times R2 must be greater, minus VDD times R1 must be greater than 0, which means Vi should be greater than VDD times R1 by R2. Okay. So what will be the so what happens? Therefore, the output will not flip from minus VDD to plus VDD right away, right? It will not declare the output as positive unless we are reliably sure that the input is sufficiently larger than 0, right? So this is basically okay. So this is minus VDD and this threshold is VDD times R1 by R2. Sanity check. Okay, when Vi is equal to V, okay. Now, when R2 tends to infinity, what should the threshold tend to do? If R2 tends to infinity, what do you expect without doing any of this math? What do you expect the threshold to be? 0, right? So, that is indeed that is one sanity check, right, because in the expression for the threshold, if you put R2 tend to infinity, that will tend to 0, correct. So, how the larger the R2 is, the smaller will be the change in the threshold. So, basically that the larger, I mean the larger the R2, the smaller the hysteresis will be, correct. So, basically when you are coming from now large negative values, this is how it looks like. Okay. And what happens when you start from a large positive value to and start going backwards, you start reducing the stuff. Pardon? Yeah. So, when the output is large and positive, then this becomes plus VDD. So, and this will become this plus VDD must be less than 0, or Vi must be less than minus VDD times R1 by R. So, minus VDD times R1 by R. Does it make sense? So, this is how this is now a non-inverting Schmitt. Okay. And this also exploits positive feedback, and is like equivalent to taking I mean what all that we did was take an inverting amplifier and just flip the signs of the op amp, and you get hysteretic characteristic, right. Okay. So,